Okay, on this one, then we're looking at transformations. So transformations can cover things like, let's write this on, symmetry. It will cover particularly things like enlargement, and that's changing the size of a shape. So an enlargement can also mean that a shape gets smaller as well as bigger. And what we use on there is called a scale factor. A scale factor is then, for example, a scale factor of 2 would mean that your shape gets 2 times bigger. Scale factor of 3, 3 times bigger, 4, 4 times bigger, and so on. Okay. We've also got translations. Translations is all about the movement of the shape. Okay, so the shape will stay exactly the same, and we would use the word like congruent. So congruent is meaning the same, completely the same. So all the angles stay the same, all of the sides lengths stay the same as well. All that we are doing is moving. So, for example, this pen, we could move left and right, up or down. We're not rotating it, we're not enlarging it. It is literally just going from there to another position. Off of there, we can get a vector to be able to describe them, but we can also talk about right, left, up, down movements as well. Words that we shouldn't be using is like across, because across is like, well, which way are you going? Another one that you could use as well as reflection, enlargement, and translations is rotation. Okay, so rotation would then be about keeping a congruent shape, but this time rotating it. So this time, obviously, my pen stays exactly the same, but all I'm doing then is just rotating it. And rotating, a bit like in netball and stuff where you pivot around a point, rotation can be in regards to where you pivot, and that will be called your center of rotation. Okay, just going back up to enlargement, rotation. That's better. Too many T's. Okay, back up to enlargement. You can have a center of enlargement, which we'll have a look at. And that's basically where you're enlarging it from. So then what would happen is that you will get an enlarged shape, but also the distance from your center point will also increase as well. So a bit like a shadow as it elongates out. What will happen is then you'd have like a, say, a gap of that would then become a gap of this because it would then increase everything. Enlarged shapes are called similar. Okay, so similar meaning all the angles are the same, but like with your picture on a phone, when you pinch it out, it then just increases it in size. So all your facial features on your picture will stay the same, but they'll just get bigger. Okay, right, so let's have a look. Knowing these words by putting one of them words in gets you 1 mark. So if we can just see what's happening on these pictures when we're describing them, straight away that's a mark. So where it says describe fully the transformation, well, I can see that I've got in large. Okay, 1 mark straight away. If you can hear my washing machine, I apologize. Next one then is it wants to know then how much. So by scale factor. So I've got this shape not printed on this bit. So I've got 1, 2, 3 squares wide there. And now I've got 1, 2, 3, 4, 5, 6. I've got 1, 2, and I've got 1, 2, 3, 4. So we can see that both bits have got 2 times bigger. So we've got a scale factor of 2. The last thing it might then want to know, particularly OCR, would be worth 3 marks. 1 mark in large, 2 mark scale factor, 3 marks for about. So the way in which you find the about, this is called the center of enlargement. So you go right angled corner to the right angled corner, draw the mark. Top, top, these are the corresponding corners. So we're going to mark. You see where it's now starting to cross. Corner, corner are the same corners on the shape. Okay, so where all the lines are crossing at that coordinate is our center point. So the distance between here to there has now increased by double as well. So we've gone 1, 2, 3, 4 up, 2 across. In theory, now we've gone 8 up. 1, 2, 3, 4, 5, 6, 7, 8, and then 4 across. 1, 2, 3, 4. Okay, so we've got 6 minus 7 as our enlargement. So again, looking at picking up the marks, I can see it's enlarged, so I'll write that word down. Do not use the word got bigger, it will not give you the mark. Scale factor, check your sides. What are we multiplying the sides by to get bigger? And then these are called rays, like rays of sunshine. We've drawn them with the corresponding corners. Where they all cross, that coordinate is where you've got it. Okay, number 2, the next transformation. So on this one, if I look at the size, I've got it's 2 squares, 2 squares, 3 squares, 3 squares. So I've not done an enlargement. The shape's not rotated round. So this is then a translation. So a translation is about moving left, right, up or down. And this is where your translation vector will come in. So a translation vector will have your X movement, which is your left and right movement first. And then below it, it has your Y movement. So it looks similar to a coordinate in the sense it's got X first, Y second, and brackets, but they go over the top of each other. Now what we want to do is pick one corner and pick the same corner on the other shape. It doesn't matter which of the corners you've picked as long as it is the same corner on both. So here I've gone for the top one. Now I want to know about which way it's going. So I'm moving from A on to B. So I've got 1, 2, 3, 4, 5, 6. So I've got 6 right. I'm then got to here. I now need to get up. So I'm now going 1, 2 up. So now I've got it up. Now it's sitting on itself by moving it across and up. What I can now do is think about this as a vector. If in doubt, write this on here, but using the vector, if we stood at this point here, everything to our right is a positive number. So that means I've got a positive at the top. When I'm stood again at this point and I'm thinking about moving up, you'll notice that all the numbers at the top are positive. So that then means I've got a positive there. So I've got 6 right, 2 up by looking there. If I wanted to move left, notice that all the numbers on the left are negative. So if I went B to A, I would have, so B to A would be -6 because I'm moving left, negative numbers on the left. I'm then got to move the shape down. Notice that below all the numbers are down. So that would be then the inverse. So this is A to B. This is what we want, but we can just show that we've got left is negative, down is negative as well as a vector. Okay, next one. If we look at that shape, again, if we look at it, it's not enlarged. It's not stayed the same as when we look at both the shapes. But what has happened is it's turned. And again, turn, not the right word, rotate is. So let's secure the first mark, rotate. And then we're going to put about, and we're going to look at how it's turned. So we want P onto Q, and we're going to look at the point, but also what we're going to look at is how much it's turned. So if I show you using some tracing paper, first of all, so I've got my shape I'm going to trace out. And I'm going to write top on here. So if I look at this shape here, when I rotate it, I need to make it look like this. I've rotated it to the left. Okay, so I've gone round to the left. Clockwise is to the right. Anti-clockwise is to the left. So I've got rotate. Let's get rid of the word about first of all. Anti-clockwise. And now I need to know about either an angle or a fraction. Doesn't matter which one you put. So I'm going from here and I've put my paper landscape. Now I'm going to turn it and it turns. Right, videos, I'm hoping it's just carried on. So I'll start again. So it says here, so I've drawn it landscape. I now want to turn it portrait. So I'm turning it to make it match 1/4 turn anti-clockwise. So 1/4. So I've got 1 mark for rotate, anti-clockwise, 1/4, 1 mark. And now I need to know where I've rotated it around. 1/4 you could also write as 90 degrees. So it just depends if you want to stick with angles or you want to stick with the fractions, it doesn't matter. So to then find out where it's rotated round, I put my trace paper on and I'm going to start and I'm going to put a center of rotation point at 0, 0. I'm going to see that if I rotate it round 1/4 turn, can you see that they're not on each other? Okay, so I'll go back to beginning. So I need it to go to the right a bit more. So I'm going to come across, just going to come across 2 squares. Right, you can now see I'm too low, so I need to go up a bit. So I'm going to move up. I'm at 2, 2 currently. Perfect. Okay, so I've got then about 2, 2 as my center of rotation as a coordinate. What's all happening in this video? Washing machine, dog, video breaking. So you've got some more questions to do there. Okay, what I will do is I'll go through just a couple of other bits on here, so you can just have a look at some of the other skills. And again, if you need me to go through anything else, just ask. This time here, reflect the shape A in the line of x equals y, or y equals x. So what that means is when x equals to 0, y is equal to 0. When x is 1, y is 1. When y is 2, x is 2, and so on. So you can see that we've got this nice diagonal line. So my reflection is going to be down and off of this mirror line. When I do these reflections, particularly with a diagonal line on these ones, what I like to do is I like to draw it on tracing paper. And what I'm going to do is I'm going to mark X and I'm going to mark another point on my mirror line. I'm going to just mark those 2 points on here and I'll show you why in just a minute. I'm going to draw the mirror line in. Then I'm going to draw my shape. Okay, so when I reflect it, what I'm going to do now is flip over the tracing paper and I'm going to link in those 2 marks there. So now I've reflected it and now I'm going to go over, press quite hard. So it should leave a nice mark. There we are. And then I can then just neaten it up with a ruler and then just make sure that all my marks are on the corners. Right, last one I'm going to just show you is number 6 in regards to just drawing and enlargement. Okay, so I've got draw the enlargement on a scale factor of 3 from the center of O. So I've got my center point here. If I want to secure all the marks, and again, on OCR, worth 3 marks. If I want to get 1 mark, I'll just make this shape 3 times bigger and draw it on the square somewhere. It doesn't matter where, as long as I don't rotate it, I just draw it 3 times bigger, I'm okay. But if I want to get all 3 marks, I need to put it in the right place. The first thing I need to do is just check the distance here. So I've got 1 square over. So now I need to make this 3 times bigger as well. So this corner now is going to move 3 squares over. So 1, 2, 3. So this corner here has now moved to there, and then I can now enlarge it by 3. So at the bottom, I've got 1, 2 squares. So 2 multiplied by 3 is 6. So I need 1, 2, 3, 4, 5, 6. So this bottom line is now going to be all the way from there to there. This line is 3. So 3 multiplied by 3 is 9. So I then need to go 9 high up to this point. And then I can then enlarge it over. So I've got 6 by 9, but it's also 3, scale factor 3 away as well. Again, 1 mark secures you, or sorry, 1 mark is secured by you drawing your enlarged shape, all 3 marks by moving it to the right place. And again, I've just picked any corner and then I've looked at the distance. So I've got 1 square to the right, times that by 3. 1, 2, 3. So my distance is now, if I look at this other point here, this corner to this corner, so on this starting point to this starting point at the right angle, 1, 2, 3. 3 multiplied by 3 is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's moved 9 across. And again, on this one, 3 across, 3 up, 9 across, 9 up by multiplying that point by 3. And again, we've got it. Okay, so have a go at those transformations. Again, if you need any help, just let me know. And hopefully this video has worked without it going kaput in the middle. Bye.